I'm going to discuss two theorems from pair of straight lines non-homogeneous equation. Those two theorems are general second degree equation in x and y represents straight lines, pair of straight lines. Then two conditions are there. I'll prove that. Second one is the same general second degree equation represents pair of parallel lines. So now we are going to discuss these questions. Now the first one is given equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So it represents two lines, right? Let the lines represented by above equation be, let the lines represented by this equation be L1x plus M1y plus N1 is equal to 0 and L2x plus M2y plus N2 is equal to 0. That implies that if we multiply those two equations, we have to get the bigger equation. By squared plus 2gx plus 2fy plus c is equal to L1x plus M1y plus N1 into L2x plus M2y plus N2. Comparing the quotients of like terms. Comparing the quotients of like terms. So like term here, quotient of x square is here. Here x square is obtained by multiplying L1, L2. Quotient of xy, quotient of y square otherwise, M1, M2 is equal to b. Quotient of constant, c is equal to N1, N2. Quotient of xy, 2h is equal to, xy is obtained by multiplying this one L1, M2 plus this one plus L2, M1. L2, M1. Next one is 2g is quotient of x here. Quotient of x is obtained by multiplying this one with this one. Multiplying L1 with L1 with N2, L1 N2 plus L2 N1. Similarly, 2f is quotient of y. Quotient of y is obtained by multiplying this one with N2 and this one with this one. So, L1 M1 N2 plus M2 N1. You have to remember this. So, M1 with N1. M1 with N1 and M2 with N1. That gives the quotient of y. Understood? Yes, sir. Now we are going to the actual theorem. Now what we need to show that two conditions are there. ABC plus 2fgh minus af square minus bg square minus ch square. For that one I am consider 8fgh. For that one, that can be written as 2h 2g 2f. Understood? What is 2h? Just now we know that 2h is this one, right? L1 M2 plus L2 M1. This one. So that is equal to L1 M2 plus L2 M1. What is 2g? 2g is equal to L1 N2 plus L2 N1. So next one is 2f. 2f is equal to M1 N2 plus M2. This is easy only, but laborious work. We have to continuously multiply that. This is equal to multiply these two brackets now. L1 square M2 N2 plus L1 L2 M2 N1 plus next one L2 into L1 L2 M1 N2 plus L2 square M1 N1 times of this bracket is as it is M1 N2 plus M2 N1. Multiply that. this one with these two now. So L1 square M1 M2 N2 square, L1 square M2 square N1 N2 plus L1 L2 M1 M2 N1 N2 plus L1 L2 M2 square N1 square. Next one is with this one those two terms, L1 L2 M1 square N2 square. Next one is plus L1 L2 M1 M2 N1 N2. Two more terms are there. With this one with this two terms, L2 square M1 square N1 N2 plus L2 square M1 M2 N1 square. First thing is that let us bring common L1 square L2 square, L1 L2 common here. Where is that common? Let us common L1 L2. So L1 L2 common is in where? So once observe that L1 L2 common here. But this is L1 L2. After that we will take M1 M2 common. M1 M2 is here. This one is M1 M2. Next one is N1 N2. N1 N2 is N1 N2 is this one is here, and one more N1 N2 is here. Once observe that I didn't mark these two terms. Which two terms? This one I didn't mark that. This one also I didn't mark. That is 2 L1 L2 M1 M2 N1 N2. So I am writing now L1 L2 common from yellow. Yellow means that is M2 N1 square plus M2 N1 square. Next M1 M2 from red color. What is that? L1 N2 whole square plus L2 N1 whole square plus N1 N2 common. What is that? N1 N2 from green. L2 M1 whole square plus L2 L1 M2 whole square. Remaining terms not marked terms are 2 L1 L2 M1 M2 N1 N2. So we have to observe here A square plus B square is equal to A plus B whole square minus 2AB. We have to use this. In each bracket this is A square, this plus the B square. So I am going to use that formula. L1 L2 times of M1 N2 plus M2 N1 whole square minus 2 M1 M2 N1 N2 plus M1 M2 times of L1 L2 plus L2 M1 L2 N1 whole square minus 2 L1 L2 N1 N2 plus N1 N2 common. We have L1 so N1 N2 times of L1 M2 plus L2 M1 whole square minus 2 L1 L2 M1 M2. The remaining two terms are as it is, plus 2 L1 L2 plus M1 M2 is L1 L2 M1 M2 N1 N2. So once let us observe that, let us substitute the values of A, L1 L2, all the stuff, L1 L2 M1 M2 N1 N2, remaining terms. So this becomes, so L1 L2 means that A, right? A into M1 N2 plus M2 N1 is 4F square minus 2 M1 M2, that is 2BC, plus B into 4G square minus 2AC plus C into 4H square minus 2AB plus 2ABC is there. 4A square minus 2ABC plus 4B square minus 2ABC plus 4CH square minus 2ABC plus 2ABC. So 2ABC cancel. This is about all 8 of GH. So 8 of GH is equal to 4 common. What is that? AF square plus BG square plus CH square minus ABC. So this is 2 times cancel. So that is equal, bringing everything in the right hand side. What we have? left hand side, ABC plus 2FGH minus AF square minus BG square minus CH square is equal to 0. This is complete the first step. Second step easy only. What we need to show that H square greater than AB. H square greater than AB means that for that one consider 4H square minus AB. Can we write this one as 4H square minus 4AB? What is that? 4H square is equal to, H is equal to 4H square is L1 M2 plus L2 M1 whole square, 2H whole square only, minus 4AB is 4L1 L2 M1 M2, that is equal to L1 A plus B whole square minus 4AB is A minus B whole square. So clearly it is greater than or equal to 0. That implies that H square minus AB greater than or equal to 0. Can we write H square greater than or equal to AB from this one? Yes. Similarly, we can prove that G square greater than or equal to AC, F square greater than or equal to BC. It completes the first theorem. The second theorem is a pair of parallel lines theorem. Given equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Let it be 1. Let the lines represented by 1b as these are parallel lines. I am taking the first two terms are same, lx plus my plus n1, lx plus my plus n2 equal 0. That implies that if you multiply those two equations, that will be equal to lx plus my plus n1 into lx plus my plus n2. Comparing the same thing what we did in the first theorem, comparing the quotients of like terms. But the slight difference is that here the x square quotient is L square only, y square quotient is m square, n is equal to c1 c2, and xy quotient is 2h, here is 2lm. 2g is x quotient, it is ln1 plus ln2, so bringing L common n1 plus n2. Similarly, y quotient is 2f, that is m of n1 plus n2. So do remember this, let it be capital 1. Once is this one, from here I am writing this one, n1 plus n2 is 2g by L, and n1 plus n2 from this one is 2f by m. These are very important things, you have to remember that. Now this is the mandatory thing we have to remember. Next one, first condition, what we need to show that h square is equal to ab, right? H square, what is h square here? H square is equal to lm, right? Lm whole square, that is L square m square. What is L here? L square is here. It is done. Second one is af square is equal to bg square. We need to consider f by g. What is f, sir? F 2f by 2g also you can consider. Consider 2f by 2g. What is 2f? 2f is equal to m of n plus n. 2f is m of n1 plus n2. This is equal to L of n1 plus n2. 2g's cancels. 2 cancel. Squaring on both sides. F square by g square is equal to m square by L square. Cross multiplication and replacing. L square is a, right? A square. This is nothing but a by b. A square is equal to bg square. Second part is done. Next one is third one, distance between the parallel lines. We know that distance between, let these equations be 2 and 3. Distance between 2 and 3 is a formula. Usually we use c1 minus c2 by root a square plus b square. Distance between 2 and 3 is equal to n1 minus n2 by c1 minus c2 by root of a square is l square, b square is m square. So once observe that a minus b can be written as modulus of root of a plus b whole square minus 4ab. Now this n1 minus n2 can be written as n1 plus n2 whole square minus 4 n1 n2 under square root by root l square plus m square. Once observe that n1 plus n2 from 1, it can be from 1. It can be written in two forms. One is 2g by l, another one is 2f by m. So that is equal to one single square root is enough. 2g by l whole square minus 4n1 n2 by l square plus m square, or if we substitute instead of n1 plus n2 2f by m whole square minus 4n1 n2 by l square plus m square. That is equal to l square LCM 4g square minus 4l square n1 n2 by l square of l square plus m square under square root, or root of 4f square m square LCM minus 4m square n1 n2 by m square comes to the denominator l square plus m square. Let us replace the values of 4 common here. 4 common means it comes out of the root, it becomes 2 only, and replace the values of everything l square m square like that. So it becomes 2 into root of g square minus ac by a into a plus b, or 2 into root of a square minus bc by b of a plus b. It completes the two theorems of pair of slightly non-homogeneous equation.